Welcome to lesson 2.10. So this is actually going to be your last section of module 2. So I guess you should be a little bit excited, right? So the first question says, we have been studying quadratic functions. Remember what makes a function quadratic. So there's kind of different ways to define a quadratic. One way might be to say it's a polynomial with a degree of 2. What that means is that it has the highest power of 2. Or you can say it is a function in the form ax squared plus bx plus c, where a does not equal 0. All right. So something important that hopefully by now you guys are kind of comfortable with, you can write quadratic functions in 3 different ways. You have standard form, which is the ax squared plus bx plus c. You have vertex form, which is a times x minus h squared plus k. And then you have factored form, which is a times x minus r1 times x minus r2. All right. It says you will notice that different forms highlight different features of the function. Okay, so I want you to keep that in mind. Each of these forms gives you different information about the function. So it says directions. For each of the following functions, write the function in the other forms, standard, vertex, and or factored, and find the features of the function. Sketch the graph of the function showing the features you found. Be sure to write the intercepts as ordered pairs. All right, so let's go ahead and get started. So first off, they gave us a function in standard form. All right. Now, hopefully by now, you know how to go from standard form to vertex form. That's the next thing they ask for is vertex form. If you don't remember standard to vertex, you complete the square. All right. So let's go ahead and complete the square on this function. All right. So remember, we always write it like this. We're going to do x squared minus 4x, and then write our 3 on the end. We take our middle term, divide it by 2, and square it, which is going to give us a positive 4. Now, one thing I want to point out, there was no leading coefficient on this guy, right? So we didn't have to factor anything out, and then we don't have to multiply this guy by that 4 by anything because there's no leading coefficient. So since we added in 4, we need to subtract out 4, and we got, and we need to write this as a perfect square in vertex form. So we're going to do x, and then you take your middle term and divide it by 2, which is going to give us a minus 2. You square it, then you combine like terms, which gives us a negative 1. So our vertex form of this parabola is going to be f of x equals x minus 2 squared minus 1. All right. Now they want it in factored form. So we got it in vertex form. Let's get it to factored form. Now, hopefully by now you guys are comfortable with factoring, right? This is one of the ones where, again, we don't have a leading coefficient, so we just need to find something that multiplies to give us a 3 and adds to give us a negative 4. All right? When I think about 3, really my only options are 1 and 3, and since it's negative, it's going to be x minus 1, x minus 3. All right? So the factored form of this parabola is going to be x minus 1, x minus 3. All right. Now, that asks for the vertex. Okay. So I want you to think about this. Which one of these forms is going to be helpful in giving us the vertex? Well, that's going to be vertex form, right? Looking here, the vertex of this parabola is going to be 2, negative 1. All right. And then it asks for the axis of symmetry. Well, the axis of symmetry really comes from the vertex, right? So you could say that the axis of symmetry information comes from vertex form, all right? Axis of symmetry is always written as x equals, and it's going to be 2. It's always x equals the x coordinate of your vertex. Next, it asks for the x-intercepts. So I want you to think, which form is going to be useful in finding the x-intercepts? Well, that's going to be factored form. All right. The x-intercepts, you get that from factored form. So what you do is you take the different factors. So we have x minus 1, we're going to set that equal to 0. X minus 2, we're going to set that equal to 0. And then you solve for x. That's why the sign switches, is because you're solving for x. All right, so that tells us that this parabola is going to go through 1, and 2. All right. Oh, goodness, I don't know where that... Hold on. Sorry, I don't know where that 2 came from. My goodness. It goes through 1 and 3. Oh, my goodness. X equals 1. X equals 3. I kind of stole the 2 from the vertex, I guess. So then the x-intercepts are going to be 1 and 3. And they would be written as 1, 0 and 3, 0. Now, one thing we haven't really talked about a ton is the y-intercept. All right. And I'm going to tell you, you get information about the y-intercept from standard form. It's actually just that value at the end, whatever your c is. So the y-intercept equals your c value. All right. So it's actually going to be 0, 3. So we know it's going to go through 0, 3. All right. Then we have our, if it's going to have a min and a max. Okay. So looking at this, we can see that this function is going to have a minimum. And how do I know that? Well, since a is positive, that means that it opens up like a cup, and I'm going to have a minimum. So if a is positive, you have a minimum. Then it asks for the domain. All right. So the domain of all parabolas is going to be negative infinity to positive infinity. All right. And then the range. The range is all, it depends on whether a is positive or a is negative, right? If a is positive, it's going to start at your y value and go up to positive infinity. All right. All right, so now we're going to go ahead and find some points for this graph. So let's go ahead and make our XY table. We're going to put our vertex right smack dab in the middle, which is 2, -1. So we end up with 1 and 0, 3 and 4. All right. So now we're going to go ahead and we can go to Desmos. And we're going to go ahead and get the y values. So I did already plug this into Desmos. And I got the y values here, which is 3, 0, -1, 0, and 3. All right, so we can go ahead and plot those. And if you notice, we actually already predicted 4 of these, right? Because we had our 0, 3, which was our y-intercept, our 1, 0, which was our x-intercept, 2, -1, which we already knew was our vertex, 3, 0, which was our other x-intercept, and then 4, 3. That was the other one that we got. So we did predict the vast majority of those. All right, let's go ahead and move on to the next one. So this time they gave us the parabola in factored form. So now they're asking for it in standard form. So to go from factored to standard, you're just going to FOIL and distribute. All right, so let's go ahead and FOIL this out. We're going to go ahead and do 2 times, and then we get x squared minus 6x minus 2x plus 12. All right, then we can go ahead and combine like terms. We get x squared minus 8x plus 12. That's going to give us 2x squared minus 16x plus 24. All right. So then when we get that, we're going to go ahead and write that for our standard form, right? Because we got y equals 2x squared minus 16x plus 24. All right. So now we're going to go ahead and write this as write this in vertex form. All right. So if you recall, to write something in vertex form, we're going to start off in standard form and factor out the leading coefficient. All right, so see what I just did? I factored this 2 out. So the x squared became a 2, and then I also factored a 2 out of the second term. Then I'm going to go ahead and take my middle term, divide it by 2, and square it. I'm going to get a plus 16. So then I need to go ahead and write this guy as a perfect square. So I'm going to keep my 2 outside, and I take the middle term and divide it by 2. That gives me my minus 4. Square it. And then, remember, and since we added in a 16, we have to look. Well, we're actually going to have to subtract out 32. All right? So we need to do 24 minus 32. And we get a minus 8. All right. So we're going to go ahead and write out the vertex form, which is going to be y equals 2 times x minus 4 squared minus 8. All right. Then we have to find the vertex. So again, let's see, I made vertex green. So the vertex we get from vertex form. So what's the vertex of this guy? You should get that the vertex is 4, negative 8. All right. So keep in mind you got that from the vertex form, right? So then axis of symmetry you also get from the vertex form. What is the axis of symmetry of this guy? You should get that the axis of symmetry is x equals 4. All right. Next, for the x-intercepts, we get that from factored form. So we got to look at our factored form, and we're going to set those factors equal to 0. So we get x minus 2 equals 0, and x minus 6 equals 0. X equals 2, and x equals 6. So our x-intercepts are going to be 2, 0, and 6, 0. All right, we can even plot those right away. We got 2, 3, 4, 5, 6. All right. Then our y-intercept, right? We get our y-intercept from standard form. That's this guy here. So our y-intercept is 0, 24. The y-intercept is always 0, something because, you know, anything that's on the y-axis is going to be 0, something. So we actually can't even plot this guy because he's like off the chart. All right. Then it asks if it's a min or a max. You actually can tell if it's a min or a max from all of the forms because the a value is pretty prevalent in all of them, right? This one, you see the 2, and the 2. So you can actually tell that kind of from all of them. And in this case, since a is positive, right, we are going to have a minimum. All right, let's go ahead, I guess, before we do domain and range, let's go ahead and make our table. Oh, God, made it nice and tiny. So our vertex here is 4, negative 8. All right, so let's go. We're going to want a 3 and a 2 and a 1, and a 5 and a 6. All right, so let's go ahead, hop on over to Desmos. All right, and notice I already plugged these into Desmos. I got 0, negative 6, negative 8, negative 6, and 0. So we're going to want a 0, negative 6, negative 6, and 0. All right, so we can go ahead and plot those. So we got 3, 1, 2, 3, 4, 5, 6. And then our 8 would be down here. And then this guy is our parabola. All right, so again, the domain is always negative infinity to positive infinity. And then the range is going to be negative 8 to positive infinity. All right, let's keep moving along here. In this case, they gave us the function in factored form. All right, so we need to go ahead and get it into standard form. So all we have to do here is, I'm going to erase this kind of in the way. All we have to do here is distribute. since you'll find out that this one doesn't have a C value. And if you recall those first ones that we factored on that finding zero sheet, when there's no C, all you can do is take an X out. So when you put that back in, you get negative X squared minus 4X. All right. So now we can go ahead and take this. The standard form of this function would be g of x equals negative x squared minus 4x. All right. And then again, we still, in terms of finding the factored form here, in finding the vertex form, we need to complete the square, right? To go from standard form to vertex form, we have to complete the square. Now, I'm sure you're looking at this and you're like, how the heck do I complete the square on this guy? Well, the first thing you want to do is factor out the negative. So you're going to have negative x squared plus 4x. All right. Then you just do it the exact same way. The only difference is that there is no constant here. All right. The c is gone, and that's why there's no constant. So we're going to go ahead, take our middle term, which is a 4, divided by 2 and square it, which is going to give me a 4. And since I added in 4, well, actually, let's look. I didn't actually add in 4. I added in a negative 4, right? So now I need to add 4 on the outside. All right, I'm sure that seems a little bit tricky, but, right, since that negative is out front, you always need to multiply by whatever is out in front. It's going to be a negative 4, so we're going to add in 4. All right, so now I'm going to write this guy in vertex form as a perfect square, so we're going to do x, and then I take my middle term, which is a 4, divided by 2. It's going to give me a positive 2 squared, and then, of course, I have my plus 4 on the outside. So our vertex form here is going to be g of x equals negative x plus 2 squared plus 4. All right, so what do you think the vertex of this guy is? All right, so look in here, the vertex is going to be negative 2, comma 4. And what is the axis of symmetry? You should have gotten x equals negative 2. All right. Then they ask for the x-intercepts. So, again, to find the x-intercepts, we want to use, actually, I guess I should have been highlighting these, right? I used green because we did vertex form. We got this information from vertex form. And then we know that we get our x-intercept information from our factored form, right? So we're going to go ahead and say negative x equals 0 and x plus 4 equals 0. So how did I do this? Well, these are the two factors, right? These are the two things I'm multiplying to give me that polynomial. So I just take those factors and set them equal to 0. So I end up with x equals 0 and x equals negative 4. So my two x-intercepts are going to be what? 0, 0, and negative 4, 0. All right. Now we've got our y-intercept. So if you recall, we get our y-intercept from the standard form of the equation. Now, the y-intercept is equal to c, but guess what? There is no c there, right? So it's actually 0, right? If c is not there, that means that it's equal to 0. So our x-intercept is going to be at 0, 0. Now I want you to look at this function, all right? Look at the a value. Is there going to be a minimum or a maximum here? There is going to be a maximum, right? And the reason for that is that a is negative. You see that here? We got negative, negative, negative. A is negative, so you're going to have a maximum. It's going to open down like a frown. All right, so let's go ahead and get our x and our y values. I'm going to go ahead and put our vertex smack dab in the middle, which is going to be negative 2, 4, negative 3, negative 4, negative 1, and 0. So let's go ahead and hop over to Desmos. All right, so when I plug these values in, I get 0, 3, and 3, 0. So I'm going to do 0, 3, 3, 0. The reason I have these set up is just for the sake of time. I know this is going to be a longer video, and I didn't want you to sit there watching me plug things into Desmos, because hopefully by now you are comfortable with plugging values into Desmos. So we can go ahead and plot. We got negative 2, 4, 1, 2, 3, 4. We've got negative 3, 3, negative 1, 3, 0, and negative 4, 0. Perfect. So this would be our parabola there. The domain, of course, is negative infinity to positive infinity. Now, since it opens down like a frown, all right, negative infinity to your y value, which is 4. Okay? So I want you to keep that in mind. Remember, I know I taught you guys this. When a is positive, your range is going to look like your y value to positive infinity. When a is negative, it's going to look like negative infinity to the y value of your vertex. All right? All right, we're getting there, guys. I know this is a long video. You're doing great. So for number 4, all right, they gave us the vertex form, right? This is y equals x minus h squared plus k. So let's go ahead and get this into standard form. All right, so to get this into standard form, we're going to FOIL this out and combine like terms. So go ahead and see what you get for standard form. So when I FOIL this out, I get x squared minus x plus 1 minus 9. Notice how there is no a value, so you don't have to distribute. If there was an a value, you would have to distribute. So we'll go ahead. I should say an a value different than 1. Technically, there is an a value. It's just 1. So we're going to do x squared minus 2x, and then we combine like terms, and we will get a minus 8. All right, so the standard form of our equation will be h of x equals x squared minus 2x minus 8. Now we need to get this into factored form. How do we get it into factored form? We are going to factor this guy out. All right, so to remind you, right, we need to figure out what multiplies to give us a negative 8 and is going to add to give us a negative 2. In this case, it's going to be, x minus 4 and x plus 2. All right. So the vertex of this guy is going to be 1. Negative 9. I don't know where I came up with an 8. Negative 9. All right. The axis of symmetry is going to be x equals 1. Now I want you to tell me what the y-intercepts would be. Or I'm sorry, what the x-intercepts would be. So the x-intercepts we're going to get by setting the factored form equal to 0. All right, we get x equals 4 and x equals negative 2. So our x-intercepts are going to be 4, 0 and negative 2, 0. Now I want you to tell me what the y-intercept would be. Remember, we get the y-intercept from the c value of our standard form. All right, so that's going to be 0, negative 8. Is this going to be a maximum or a minimum? It's going to be a minimum, all right? And then the domain is negative infinity to positive infinity. And then the range is going to be from, or actually I want you to tell me the range. What would the range be? In this case, the range is going to be negative 9 to positive infinity. So let's go ahead and come up with our table. Our vertex is 1, negative 9, so we're going to have 0, negative 1, 2, and 3. We can go hop on over to Desmos, and we get negative 5 and negative 8, and negative 8 and negative 5. All right, so we can go ahead and plot these. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. And then we've got 0, negative 8. Notice that is our y-intercept, right? We already came up with that point. And then we've got negative 1, negative 5. 1, 2, 3, 4, 5. And we've got 3, negative 5. And then we also, since we already have our x-intercepts, let's go ahead and plot those too, right? We get 4, 0 and negative 2, 0. All right, so why does this look wonky? Oh man, I messed up a little bit there. Let's see, this guy's got to go there. And then we've got our 3, negative 5. There we go, that looks a little bit better. And then we've got our 4, 0, 1, 2, 3, 4. There we go, that looks a little bit better. So we got some extra points in there. We're working hard today. All right. We will discuss the rest of this in class.